Hi everyone, this is Mr. Mohammed. Today we're going to be talking about permutations versus combinations. Basically, today we're going to be focusing on the major differences between permutations and combinations by understanding how we actually look at each scenario and how we decide which kind of formula to use. So the first thing that we're going to be talking about is a definition of permutation, which actually you don't learn much from the definition itself. It's the selection of items where order matters. So basically, if we have three balls like this, all of them are identical, as you can see. Well, permutation is not going to work in this case, so we got to give them like colors. So what I did is give three different colors, like yellow, red, and green. And we are going to see how we can actually arrange those three balls, or in how many ways can we arrange three different colored balls. So the first color we can choose is yellow, and then red, green. So we have to start with yellow twice, and with red twice, and with green twice. And these are all the combinations that you can think about. So I'd like to ask you guys to pause the video right now if you'd like to go ahead and see if you actually can come up with another combination, right? All right. So basically, like as a rule of thumb to start with, that there is an n factorial ways of arranging n objects in order. And this is actually an intuitive rule. As you can see, when I had three different colored balls, I had 6 ways of arranging them. Right? That's 3 times 2 times 1. That's 3 factorial. But imagine that you have like 100 balls. It's going to be the same thing, 100 factorial. So counting is going to be a little bit bigger, but it's the same concept at the end of the day. So if you understand that if you need to arrange n objects in order, you have n factorial ways of doing so. All right? Combination is the selection of items where order actually does not matter. So if the order doesn't matter, so we're not going to actually have to have any different colors because, order is not very important in this case. So you have only one way of arranging n objects where order does not matter. Because think about it, all of them are identical. So it doesn't really matter which one comes first. That's combination because it's not really important to know which one comes first. So the number of combination in this case is 1. No matter how many balls I have, actually, even if I have a 50 balls, right? So if I have 50 balls, I need to arrange them where order does not matter. You have only one way to do that because you're not really interested in differentiating between who comes first, who comes second, and who comes last. So that's combination. That's why I didn't give those balls any colors, right? So what if we actually need to pick only a certain number of items from a pile? So instead of actually arranging all the items that I have, I need now to pick or select. Those are the keywords. So we need to select or pick a certain number of items from a pile, right? So I have 5 steps for you. They're going to be easy for you guys if you follow them correctly. So the first one, you have to read the situation very carefully, right? And then you need to decide whether it's permutation or combination. And we're going to show you how to do that in a minute. And then if you cannot actually decide, try to project on a similar situation that you have heard in class or a similar situation that you've encountered, right? So for example, instead of just like having 3 different colored balls, maybe you have, like friends or people or cars. So try to project the ideas that you know on something that you've already familiar with. Next, you have the right formula. Of course, we have 2 formulas for permutation and combinations, NPR and NCR. You might have seen them in your algebra class. We're not going to be doing them today, but you've seen them before. And then we need to evaluate and then check our work, right? So here's some situations. I have 4 situations for you guys today. If you need more questions or anything, you can always research online. You can always look at the book or, ask your teacher, right? So in how many ways could we select 3 champions for the first, second, and third places out of 12 candidates? Now, as you can see here, I have only to choose 3 out of 12, right? But the thing is, I have to arrange them in order. So the first, the second, and the third, right? Like in sports, the first one gets gold, second gets silver, and third gets bronze. So basically, it is important that we have to put them in order. That's why I say this is a permutation. And the reason why, because the order matters, right? So it's a permutation question in this one. And if you'd like to solve it, it's 12p3. And there is a way to do it using the permutation formula that we can see in another video. In how many ways could we select 3 students out of class of 12? Well, this may seem like the same exact scenario that we've talked about. But if you think about it, if you choose any 3 students, that will suffice. It will be okay. So just choosing 3 students out of 12. Maybe those 3 students are going to be helping their teachers. Or maybe they're going to have a specific project. So 3 students, not a specific order. You can just choose any 3 students. That's why this is a combination, even though you're choosing 3 out of 12. Next situation is, in how many ways could we arrange 4 books on a bookshelf? So these are 4 different books. Like you have 4 different books, like let's say algebra, calculus, geometry, and trigonometry. I need to arrange them on a bookshelf. So basically, it is important which one comes first, or at least you have many ways to arrange them if you think about it. So it's not just one way. So how many ways can we arrange 4 books on a bookshelf? Now here we're not actually picking from a pile. We're going to arrange those books, right? So basically, it is going to be a permutation situation because, it's going to be different if you put algebra first and trigonometry second, etc. So you have different permutations. And the answer to that question should be 4p4, which is the same as 4 factorial. In how many ways could we arrange 4 of the same books on a bookshelf? Now, here's the thing. You're working in a stationery, you have the same book of algebra, and you're selling, you have a multiple editions, or you have the same exact book that you're selling, right? And you'd like to just put them on a shelf, so all of them are identical. So they are not different in any way. So to arrange them, you have only one way of arranging them. You just put first, second, third, fourth, and because they all look the same, it's a combination scenario.